Let's look at another example of how we can use a table of values, an input-output table, to graph a linear equation. This is a linear equation. We have an x and a y, and so our solution is going to be an ordered pair. It's going to be an x value and a y value. So again, what we want to do first is we want to solve for y. If you put the work in up front, it'll make the problem easier later on. So again, we're going to solve for y. I'm going to go keep, change, change. So I'm going to solve for my negative 2y by getting rid of my 3x first. I'll subtract it from each side. These cancel. I'm left with negative 2y equals 6 minus 3x plus a negative 3x, however you want to think of it. And now, since I want to solve for y, I'm going to get rid of my negative 2 by dividing everything by negative 2. Negative 2 divided by negative 2 is 1y. 6 divided by negative 2 is negative 3. Negative 3 divided by negative 2, well, negative divided by negative is just going to be a positive 3 over 2x. Now, in this situation, it would be okay if you were to write this as negative 3 plus 3 divided by 2 is 1.5x. Okay, I'm okay either way you want to look at it. Okay, and what our goal is we're going to graph it on a coordinate plane. So once we have that, now we can make our input-output table. So I'm going to have the x values I select. I'll have my work column here, negative 3 plus 1.5x. And that'll give me my y. And if you need to, then you can also have your ordered pair, your solution column. So if we're looking at this, you get to pick whatever x values you want. Okay, again, I'm going to try negative 2 again, because I like using negative 2, 0, and 2. It just gives me a little space on the graph. So if I have negative 3 plus 1.5 times the negative 2, if you just type that into a calculator, you will get a negative 6. So that becomes the point negative 2, negative 6. Okay, so if I wanted to plot the point negative 2, negative 6, go to negative 2 and down to negative 6. Okay, now let's say I want to try 0. Negative 3 plus 1.5 times 0. Negative 3 plus 1.5 times 0. Let me fix this here. Well, 1.5 times 0 is 0. 0 plus negative 3 would just be negative 3. So I get the point 0, negative 3. Okay, so let's plot the point. 0 means I don't move left or right at all. Negative 3 means I go down 3. Now, with these 2 points, I am able to draw a line. Extend the line out, put arrows on both sides, because again, this line represents all solutions. Okay? Now, the reason I have you do another point is because we need a test point. We need to see if we did it right and didn't make a mistake with these 2. So if we did it right, then our third point should lie somewhere on that line. So I'm going to try 2. Negative 3 plus 1.5 times 2. Again, I'll just type that into my calculator, and I get 0. So this should be the point 2, 0. If we did this correctly, that should be on our line. Okay, so I come over here, 2, 0. Now I'm off a little bit, but that's more just a problem with my line. I actually did it correctly. If I would have made my line, or draw my line straighter, or through the points, we would have been good. But you can see that that third point lies right there on the line. Okay, that tells me I probably did this correctly. I probably didn't make 3 mistakes or 2 mistakes. These 2 points create the line. The third one tests to see if I'm right. Where did negative 2, 0, and 2 come from? I picked them. You can pick whatever you want. I do advise you, though, to keep them close to 0. I recommend using 0 because it usually is pretty easy, and I also recommend trying a negative and a positive. But again, Our original equation was 3x minus 2y equals 6. This line represents all the solutions to that. So if you take a look right here, it looks like it crosses the grid lines at this point. This is the point 4, 3. So let's test point 4, 3 to see if it works in our original equation. Our original equation is 3x minus 2y equals 6. 3x minus 2y equals 6. Now what I did is I picked a point off of our line, because I said our line's all the solutions, the point 4, 3. So let's test, the point 4, 3. This is our x value, this is our y value. So if I plug 4 in for x, I'm going to go 3 times 4 minus, for the y I'm going to put a 3, 2 times 3, that should equal 6. 3 times 4 is 12, minus 2 times 3, which is 6. Does that equal 6? Yes, it does. Okay, so this is a solution. Again, every point on this line is a solution. So when given an linear equation, ladies and gentlemen, solve for y, that's function form. Select at least 3x values, plug them into your equation, get your points, and when you're done, draw a line through the points and code arrows at the end.